What is going on, everybody? Welcome back to another video, Cup of Code 01, and sticking true with the job interview array algorithm questions, we have yet another one. Today we are knocking out missing numbers. This is also going to hit something called, that I have just sorted here to understand the sorted method that exists within, or the sorted function rather, that exists within Python. Now again, arrays is just, it could be called something different language, but in Python, the array is going to be either a list, a tuple, or a dictionary that we're utilizing. So we're going to be dealing with lists for this one here. So what is this challenge, if you will? What is the missing number? So we're going to call this one missing numbers. So we're given array 1 and we're given an array 2. Array 1 is a non-negative number array, and array 2 is a shuffled version of array 1, and one integer is also missing. So we want to create a function that's going to find the missing number. So if we had a function called finder and we passed through it this first array, 1, 2, 3, 4, 5, 6, 7, the second array is going to become a shuffled version of that. So we have 3, 7, 2, 1, 4, 6, and one of the integers is missing. So which integer is missing? We can see off the bat just by looking at this, we can see it's number 5, but we want our function to tell us exactly what that's going to be. Now this is a great example because within this particular exercise, we're going to find that we can create different big O notations, different performance levels, just by a different algorithm. So with that being said, again, all this will make more sense as we go through it. 1 as we code it, and then 2 as we debug it. It'll all come together in your brain. So what are we going to do first off? So let's give it let's go a very simple way, a naive way of thinking about doing this. I would just create our function, and we're going to pass through it array 1, and we're going to pass through it array number 2. All right, fair enough, nothing crazy yet. And then what I want to do is we want to sort these arrays, right? Because again, it's very easy if we sort them, we can start to then find what the missing number is going to be if they're in the same order as far as the computer is concerned. So for array 1, I just want to sort it. I'm just going to call the sort function on array 1, and the same thing for array 2. We want to sort those. Array 1, sort. Array 2, sorted. Easy peasy. Now, for those who may not be familiar with sorting, I just wanted to show you real quick here on a sort. And I'm using the what we had for the anagrams before, where Clint Eastwood has the same letters as Old West Action. I just wanted to show you exactly what the sorted function is going to be doing if you take an element that in this case has a string and you sort it. What is it actually doing? So what I want to do here, I'm just going to highlight this and we're going to execute it in the console. Sorted test, yes. So I just want you to first off see what the sort is doing in this case. So we have our 2 strings we passed through. So the first one was sorted. There's 1 space. So spaces take a priority first off. So there's 1 space. So it's showing me the first sort in this array, in this list, is a space. And then it's going to give me capital letters alphabetically. So I have a C and I have an E. So it's giving me those sorted alphabetically, individual elements within the string. And then it's going to do alphabetical, the lowercase elements. And you will see if we have repeats, it will repeat them and they'll be in order, which is actually good to know. And then for the next S2 variable, we have 2 spaces, we have 4 capital letters. So we have in our array, the list array, 2 spaces, 1, 2, 3, 4 capital letters in alphabetical order, and then the lowercase letters in alphabetical order, and of course letters that are repeated. So you can see how this would have been very easy to do with the anagram which we did, where first we just got rid of these spaces, so that would have been taken away from this one, and these would have been taken away from this one, leaving us with just letters. Then we're making everything lowercase, and then when you sort everything, it's a lot cleaner. Then you have everything. Then you can just go element by element and see if things are matching up, if the length is the same, and if the sorts are identical. If the sorted S1 equals the sorted S2, then you know we're good to go. Of course, if we made a lowercase and we got rid of the spaces, which is anagram 1. That was our first question that we did, but I just wanted to show you guys what the sort function was doing within Python. So now that that's done, let's go back to our second one here. So we're taking our first array, we're sorting. We're taking our second array, and we're sorting. And we see we have no spaces in our array. We're not doing uppercase, lowercase, so we don't have to worry about it. So if we ran them at this point, you would just see literally a sorted list. Our first list is already sorted numerically. Our second list is not. It would be sorted, but then we could quickly see the difference between the 2 lists if you wanted to print this out. So at this point, you could, if you wanted to, you could hit, or you could do if you wanted to see what this is going to look like. If I did this. Just want to quickly do this so you can see what I'm talking about. Neither, so let me go over here and go missing. So I just wanted to quickly show you, if I just quickly created, if I made the return array 1 and 2, creating variable x, running, calling the function we created, passing through it the two arrays we're going to pass through, it will quickly just, the function all we did so far was sort. We sorted array 1, which was already sorted, and we sorted array 2. So now if you were just comparing the two, you're going to say, all right, element 0 should match, element 2 should match, element 3 should match, element 4 should match, element 5 should match, and when you get to 0, 1, 2, 3, 4, you're going to say, nope, there's a 5, there's a 6, they don't match. So we can find out quickly which number is missing. So let's get rid of this though, because that's not what we're doing for this algorithm. So we're sorting our two arrays, and now we're going to do a quick little for loop here. So for number 1, because we have two different arrays, and num2 in, whoops-a-daisy, in zip, we're going to call the zip method within Python. And this is very similar to what I just showed you in terms of lining up what you can see here. It's going to be very similar in terms, the zip function is going to match indexes. Index 0, index 0, index 1, index 1, index 2, index 2. That's what the zip function is going to be doing within Python. So, and that's just called tuple unpacking, essentially, is what we're going to be utilizing here. So this will make sense if num1, remember, does not equal num2, and this is after we zipped it, so we're saying index, even though number 1 and number 2 are going to have values from based on our array, if the index 0 number does not match the index 0 number 2, what do we want it to do? So what we want to return something in this case. So what we're going to return, we want to say, give me return number 1, give me number 1, because we know it's an array 1 has the full list of numbers. Array 2 is missing one. So if the index number at 1 does not match the number at the same index position in 2, give me that number 1, because now I kind of understand what's missing. Because in that meaning, in this case, when I got to index of 4, I want it to give me the number 5 back, because now I know what's missing in this list. That's a very quick way to understand what's missing. So I want to return the number 1, and from an else statement, what I want to be doing is we're just going to another return, and this will make sense to you as we run through with the debugger. All I'm telling you here is give me, out of array 1, give me the last element that's in array number 1. If it makes sense or not, we'll find out. So again, I wanted to show you really quickly. I could have, you can run that on your own. If you ever wanted to see what the zip function's doing, you can run the zip on like one array, 1, 2, 3, and a second array, 4, 5, 6, and you can see how it's going to match the index 0 with index 0, and so on, just so you can understand how the index matching is going on when it's doing its code. So let's do this. Let me go up and take what we used before. These are the arrays that we're going to use to run this particular code here. So we're going to, let's debug it. Let's see how we get. We're debugging missing number. You can go down, my dear friend. All right, let's FA through again. We have to call the function first off. That's why it jumps to the last line. So now we have in memory, we have two arrays, array 1 and array 2, and that's simply just going to be the variables that we put in within the function finder below. So first, when array 1 sort, it's already sorted, so its memory is not going to change anything. Array 2 sort, you can see here with 37214, and when I execute this line in memory, array number 2 is now sorted 1, 2, 3, 4, 6. So now we're saying for num1 and num2. Let me let me just also. Oh, you're not giving me that option now. Well, that's rude. I guess I can't do it now. I was going to go in and just do soft wrap so I wouldn't have to go like this. So you can see that last element. Well, for number 1, number 2 in zip R1, R2. So taking R1 and taking R2 and using the zip function on this, what we're saying is match up index for index. Index 0 to index 0, index 1 to index 1, regarding for array 1 and array 2. And we're just comparing those numbers. If the number 1 does not match number 2, return number 1. If it does, then return that last element within array 1. So we're going to F8 through this. So number 1 is 1, number 2 is 1 in terms of zipping with the indexing. So index 0 is 1 in both arrays. Awesome. So we go back up because that was true. I'm sorry, it was false rather. So we go back up in our for loop because they did match. Number 1, we're going to F8 is now we have 2 and 2. So at index 1 in both arrays, the number is 2. So if number 1 does not match, that's false. So we're going to go back up to our for loop. Now we have 3 for index position 2, that's false. Now we have 4 for index position 3, that's false. Now we hit a true. If number 1 does not equal number 2, that is true. We want to return number 1. And then we jumped out of our loop because that were it. We were done with our loop. So now we're going to see in our console, we printed out, we returned number 1 in console. So now we have our missing number within the list. In terms of the R-1, that was simply going to be if they were all going to mix. If they were all going to match up, then it was the last number that was pulled off, meaning that was the point of this function here. So actually, I'll do that for you. Let me, in the array, we'll do it here. I'm going to keep that 7. We're going to add a 5. Oops. And I'm going to take that 7 away. So now the missing number is 7. All right, now this line, this return of code will come into play. Now when I run, when we debug this bad boy again. So debug it, missing number, it's gonna reset the console. Excellent, we'll go to console so we can see it. All right, so F8 through it. So again, same thing, same variables, only difference is now the number we took off was 7 because we want to see this last line of code come into play. So array 1 and array 2, they're both sorted. Excellent. Number 1, 1, 1. That's true. 2, 2 is true. 3, 3 is true. 4, 4, well, it's true, but in regards to if number is not equal, it's false. But that's why I jump back into the for loop. 5, 5, 6, 6. Now you see what happened was it jumped out. Why? Because there were no more numbers within the second array. There were in the first. So now it's saying return the last element in the first array because that must be what's missing. So if I F8 through this in my console, I better get, yep, and I got a 7. So if you go through this element by element, you can see that when we indexed these, they matched index of 0, 1, 2, 3, 4, 5. But this guy had an index of 6, but there is no index of 6 over here, so it would not have computed within this for loop. This for loop, when it's running number for number in the zip is matching indexes. So this number, when it does the zip, if you printed out R1 and R2 after it was zipped, number 7 ain't gonna be there within the zip format because there's no index matching up for the 7. You'd get an error. So when I run through this code, all of these come out as if number 1 does not equal number 2, well, that's false. They all are going to equal. 1, 2, 3, 4, 5, 6 are all going to equal the numbers in this that are sorted. So what's going to happen is this part is going to be false, so it's going to run down to the next executable line of code, which would have been here, just for this element. And then it would say return array 1, go to -1 index position, which is -1 index position. Give me that 7, because it didn't have an index match when we were using the zip function. So, like always, play with it. This is only one solution. Now, if you were to do this, if you looked at this, we have a for loop, and then we're running an if statement inside of it. So, if you were going to create and time this as a big O, it's not the most efficient way that you could have been utilizing this. So, with that being said, we don't want to get well, what we did was we compared the second array to the first array to see if there were duplicate elements, essentially, by utilizing the zip function. This would be an O n to the n squared, since we're doing a nested loop. So we have a nested loop here, so this is going to be n squared. So we can, if you can recall from the graph what n squared looks like, there's better ways to do it. And that's what we're going to do in the next video. We're just going to run through a different variation of this. We have 3. Another variation is going to give us to a big O of a log n, and then we're going to finally get to a big O of just n. So we can have a linear time and constant space constraint within our big O notation.